Hi students, welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. In this class, we are going to discuss general science, important MCQs on the topic electricity. Okay? Yeah. Here the first question. Here the first question. That is, what is the SI unit of electric charge? Electric charge is denoted by the letter Q. And coming to the units are coulombs. Coming to the units are coulombs. Very important question and very basic question. Here coulombs is the correct answer, and volt is nothing but unit of voltage, and ampere is the unit of current, and ohm is the unit of resistance. Okay, and the next question is, a current of 5 amps is drawn by a filament of an electric bulb for 10 minutes. Then what will be the charge? What will be the charge? And we know very well what is the current. What is the current? Current is nothing but rate of flow of charge. Rate of time is nothing but rate. Rate of flow of charge is nothing but current. Or we can also say that rate of flow of charge is nothing but current. We can also define this current as flow of electrons. Flow of electrons is nothing but current. From this, we know very well the units of current are amps. Okay, and units of charge are nothing but coulombs. And the units of time is nothing but seconds. Nothing but seconds. So 1 amp is nothing but we can say 1 coulomb per second. Okay, and here the very important one, we have to find out the charge. Q is equal to I into T. Q is equal to I into T. That means here all the options are in coulombs. Then we have to use the current units are in amperes and time units are in seconds. Okay, so Q is equal to I is nothing but they have given 0.5 amps. Current is nothing but they have given 0.5 amps, and time they have given 10 minutes. 10 minutes. But we have to convert this minutes into seconds. Okay, why? Because we want to find the charge in coulombs. So then 0.5 into 10 minutes is equal to, we know very well 1 minute is equal to 60 seconds. That is 10 into 60 seconds. That is, you can say 600 into 0.5, that is 300 coulombs. So we got the charge as 300 coulombs. Okay, so option D is the correct. Option D is the correct. Once again, they have given the current, they have given the time. They have given this current value and given time value. We want to find the charge value. So charge Q is equal to I into T. If you substitute the values, then you will get the answer coulombs. Okay, don't forget, here we have to convert this time into seconds like this. Okay, and the next question. The next question is 1 ampere is equal to dash. The options are 1 coulomb per 1 second, 1 second per 1 coulomb, 1 second 1 coulomb, 1 ohm, 1 volt per 1 ohm. Here we have already discussed the current I is equal to Q by T. The units of current are amps, and units of charge is nothing but coulomb, and units of time is nothing but second. So 1 amp is equal to 1 coulomb per second. So option A is the correct. Option A is the correct. And the next question, which opposes the flow of current? Here, which opposes the flow of current? We can say the term, that is the component resistor. Resistor is a component which always opposes the flow of current. Which opposes the flow of current. Flow of current. That property is nothing but we can say resistance. We can say resistance. This resistance always opposes the flow of current. It is always opposes the flow of current. Okay, it opposes the flow of current. So here, according to the option, The resistance is current. Resistance is opposes the flow of current. And coming to this capacitance opposes the sudden change in voltage. The sudden change in voltage. Remember one thing friends, capacitor is always voltage phenomena. That is, capacitor does not allow the sudden changes in voltage. That means it is opposes the sudden change in voltage. Okay, and in the same way the inductor I inductor, this inductor opposes the sudden changes, only sudden changes friends, not total change. The sudden changes in current. The sudden changes in current. It opposes the sudden changes in current. Some students, that is not belongs to electrical or electronics engineering, they will confuse on this. I have a trick to remember this. In inductor, that is what is the first one? The first letter I. In inductance, the first letter is I. That means it does not allow the sudden changes in current. Like that you can remember. The remaining is nothing but capacitance. Inductance does not inductance. The first letter is I. That means it does not allow the sudden change in current. The remaining is capacitance. Capacitance does not allow the sudden change in voltage. Like that you can remember. Okay, and coming to the resistance always opposes the current, flow of current. Okay, here remember this capacitance and inductance does not allow the sudden changes only. Suddenly any changes, then only it opposes. Okay, the next question. Next question, resistance of wire is directly proportional to dash. Resistance of the wire is directly proportional to dash. What is this resistance? We have already discussed. Resistance is nothing but which opposes, resistance is denoted by the letter R, and it always opposes the flow of current. Flow of current, and this value is given by R is equal to rho L by A. Rho L by A. This L is nothing but length of wire. Length of wire, and A is nothing but area of the wire or any conductor, and rho is nothing but resistivity. So from this we can say it is resistivity is nothing but it is the nature of material. It is mainly depend upon nature of material and also temperature. That means it may not change. It is based on their nature. That is, if it is a steel material, iron material, or any aluminum material like that. That is based on that material. So from this we can say resistance is directly proportional to the length, and resistance is inversely proportional to the area. Inversely proportional to the area. So according to the question, resistance of the wire is directly proportional to length of the wire. Option B is the correct. Option B is the correct. And the next question. The next question. In conductors, as temperature increases, resistance will be dash. Resistance will be dash. Here this resistance also depends upon the temperature. It depends upon the temperature. How it depends upon the temperature means, we know very well we have conductors and also semiconductors, and also we have the insulators also. Okay, but if you consider mainly conductors, in case of these conductors, as temperature increases, in case of conductors are nothing but which are allow with the materials which are allows the electricity through them. Those are nothing but conductors. In this case of these conductors, for example any aluminum or copper, these are, we can say, conductors. These are easily allows the electricity through them, so we can say these are conductors. In case of these conductors, as temperature increases, resistance also increases. Resistance also increases. So we can say these are positive temperature coefficient of resistance. These are positive temperature coefficient of resistance. And coming to the semiconductors are insulators. But we will not consider mainly the insulator. Why? Because the resistance of insulator will be very high. Why? Because these does not allow the electricity, that these are does not allow the current. If there is this does not allow the current means there is no value of current means what about the resistance? Resistance will be very high. We know very well resistance is opposes the flow of current. That means both are inversely proportional, we can say. If a material having high resistance will flow, that is will allows the low current through it. If the resistance is low, then we can say current is high. Okay, so in case of semiconductors or insulators, mainly as temperature increases, the resistance will be decreases. That means if we increase the temperature, the resistance of the semiconductors will be decreases, then the current will be increases. Here also same. If the conductors as temperature increases, the resistance also increases. If resistance increases means current is decreases. Okay. Here temperature increases, current decreases means we can call this as negative temperature coefficient of resistances. Okay. And the next question. That means here as temperature increases, resistance will be also increases. Option B. If they will give the question on semiconductors, then will be the answer is decreases. Okay. And the next question. A wire has a resistance of 10 ohms and it is stretched by 1/10 of original length, then its resistance will be dash. That means they have taken they have given one resistance R1, let us take 10 ohms. Okay, and if it is stretched by 1/10 of original length, that is length will be increased to 1/10. Initially we can take it as 10 meter. It is stretched by 1/10 again, that means it will be 11 meters. Okay, that means we can say L1 will be 10 meter, L2 will be 11 meter. That means L2 by L1 we can say 11 by 10. We can say 11 by 10. And we know very well for the given value, area into length will be same. Area into length will be constant. That means if the length increases, what happen? Area must be decreases. That is both are inversely proportional here. Here for the given value, both are inversely proportional. That means as length increases 1 point, area will be decreases by 1 point. Okay, that means here we can say if the area, let us take A2 will be 11 meters square, then area 1 will be 10 meters like this. Why? Because these two are inversely proportional. That means here the length is increases 10 to 11. This area will be decreases from 11 to 10. Why? Because these two are inversely proportional. Okay. That means we can say from the equation R proportional to L by A. Here length increases by 1 point means 1/10 or 1 point means resistance increases by 1 point. Why? Because directly proportional. And we have from this, that is for the given value, for increasing of length 1 point means area will be decreases 1 point. That means if the length increases 1 point means area decreases by 1 point. Okay, and from this relation, if the area decreases, then what happened to the resistance, friends? That is both inversely proportional. If the area decreases 1 point means resistance again increases 1 point. Again increases 1 point. Got it? Got it? Here, if the length increases 1 point means here resistance is directly proportional to the length, so resistance is increases by 1 point. If the length increases means for the same value area decreases by 1 point. If the area decreases means R and A are inversely proportional. So if the A decreases 1 point means R increases by 1 point. That means R is increases to 2 points. 2 points. That means you can say they have given initially it is 10 ohms. Then due to these 2 points 10 plus 2 nearly that is 12 ohms. Nearly 12 or 12.1 ohms. That is 12.1 ohms is the answer. 1 ohm is the answer. Okay. Or if you want in the calculation method you will also get that is L2 by L1 is equal to 11 by 10. Then area A2 by A1 will be 11 by A2 by A1 will also be if A1 is equal to let us take 10 meter then A2 will be 11 meter. Okay, that means here also we will get the same one. Then the resistance will be the R2 will be R1 into 11 by 10 whole square. 11 by 10 whole square. That means 12.1 by 100. That is 121 by 100. That is 121 by 100. Okay, 121 by 100. That is we can say 1.21 into R1. R1 is 10 ohms. We can say 1.21 into 10. That is we can say 12.1 ohms. So R2 will be 12.1 ohms. In that way also you will get the answer. That is here length L1 is equal to 10 meter. If it is stretched to 1/10, the length 2 will be 11 meter. Length 2 will be 11 meter. Okay. And if you take A1 that is area before any stretching area will be 11 meter. Then if you if the length is increases then area will be decreases. Then A2 will be it is 10 meters like this. 10 meters like this. Okay, that is your assumption. Based on your assumptions you will get the answer. Okay, if the length is increases from 10 to 11 meter then the area will be decreases from 11 to 10 meter. It is the concept. It is the concept. Just remember this one. Or if you don't want this type of that is a complicating one, just use this method. R is equal to L by A. If the length is increases, area also increases. If the length increases 1 point, then automatically area decreases. If the area decreases means resistance increases another point. That is both 2 points. It is increases by 2 points. That is 10 plus 2 that is equal to 12 ohms. Option C is the correct. Okay. And the next question. Next question. 1 volt is equal to dash. We know very well voltage. Voltage is nothing but it is the energy. It is the energy given to flow the current. To flow the current. It is the energy given or energy required to flow the current. And this value V is equal to we can also define as work by charge. Work by unit charge. That is how much of work done in a particular or in a unit charge. In a unit charge. So voltage V is equal to W by Q. W by Q. And voltage units are we can say volts. Volts. Here 1 volt is equal to. Here W units are joules. Work units are joules. Per charge units are coulombs. So joule per coulomb. So we can say 1 volt is equal to 1 joule per 1 coulomb. So option B is the correct. 1 joule per 1 coulomb. And the next question. Next question. How much work done in moving a charge of 2 coulombs across 2 points having a voltage of 12 volts? Having a voltage of 12 volts. That means 2 coulombs charge means they have given Q is equal to 2 and they have given voltage V is equal to 12 volts and they are asking about work done W. We know very well V is equal to W by Q. From this W is equal to V into Q. V they have given 12 volts and Q they have given 2 coulombs. 12 into 2 that is 24. 24 work units are nothing but joules. 24 joules. Option C is the correct. Option C is the correct. Okay, that is, problems are very simple if you know basic formulas. If you know basic formulas. Okay, and one more thing, one very important thing friends, that is I am taking special live classes, in Unacademy Plus platform. Unacademy Plus platform. You can also access those special live classes with the free of cost. With the free of cost. For that, you have to just do one thing. You have to get free registration for that. How to get free registration for that. Okay, how to get this free registration to that? Just I am showing that. Just open your browser and for that just you have to open your browser and click on unacademy.com. Click on unacademy.com. Then you will get here plus button. Click on plus button. In this plus button you have to select your goal as railway examinations. Railway examinations. If you select your goal as railway examinations, then you will get here the topic, that is experience plus for free. Here click on see all. If you click on see all, you will get all the free classes. You will get the details of all the free classes. That is, if you want any free class, just open. For example, for me, here there is tomorrow Sunday. Tomorrow Sunday we have I have two classes, that is here general science important MCQs on electricity for RRB NTPC. For that just click on that. Okay, in that you will get, actually I have logged in now. I have already logged in, so but you will get here one tab, that is get free registration. Here in this time with there is in this we will notify you when the class is live. Okay, here you will get one option, that is get free registration. Just click on that link and you will get registration. And one more thing, just open unacademy.com. okay, here search for my name. In the search button, search for my name, Sunil Kumar Bandaru. Click on that. Here you will get my profile educators. In this you will get my profile Sunil Kumar Bandaru. If you click on that, here you will get, that is one button, that is follow me button. Follow me button. Then click on that follow me button. If you follow, then whenever I will take any special classes, that is free classes, you will get notification. So don't miss this opportunity, use this opportunity. Okay, for example, if it is like this, just click on Sunil Kumar Bandaru. You will get my profile. Okay, here you will get one button, that is follow button. Have you got it now? Follow button. Just click on follow button. Okay, and if you don't have any your account, just register with your mobile number. Okay, then you will get registration. And if you follow me, then whenever I will take any classes, you will get notification. Okay, for this also, for my classes, here just click on that. If you click on that, then you will get how the option, that is notify me or get free registration option. Just click on that, then you will get registration. Okay, that means before 30 minutes of class you will get one notification. After that, then just click on that link and you will go to the, you will have the access to this class. And if you watch, that is nearly 20 to 30 minutes of this live class, then you will also get PDF of this class also. You will get also PDF. Okay, but you must watch at least 30 minutes or 25 minutes like that. Then after 1 hour, you will get the option here PDF, get PDF. You can also download the PDF. Okay, yeah. Now we are coming to the class. The next question will be, Ohm's law is not applicable to dash. Here this Ohm's law is mainly applicable to ohmic materials. Ohmic materials, those are nothing but conductors. Those are nothing but conductors. That means this Ohm's law mainly applicable to conductors. It is not applicable to semiconductors, not applicable to electrolytes, and not applicable to insulators. Sometimes they will give the question, they will give the option like diodes and transistor. These are belongs to semiconductors only. So for this also Ohm's law is not applicable. So Ohm's law is not applicable to all these. So option D is the correct. Option D is the correct. And the next question. Conductance is expressed in terms of dash. Conductance is expressed in terms of dash. Here conductance is nothing but it is the property of the material, that is in which it will allows the electricity. It will allows the electricity. This conductance is nothing but it is the reciprocal of resistance. You can say reciprocal of resistance. Conductance is denoted by the letter G and it is the reciprocal of resistance. And we know very well resistance units are ohm. So conductance units are 1 by ohm or ohm universe. This ohm universe we can say mho. Mho, the symbol is like this. Okay, and we can also call this mho as Siemens. So the units of conductance are mho or Siemens. Here in the option they have given ohm no, ohm meter no, ohm per meter no. So mho is the correct. Mho is the correct. And the next question. Resistivity is expressed in terms of dash. Resistivity, that is denoted by the letter rho. And we know very well R is equal to rho L by A. From this rho is equal to RA by L. RA by L. We know very well the units of resistance ohms and units of area will be meter square and the length units are meter. So meter cancel. These two meter and meter goes to movie. Then we will get only ohm meter. So the units of resistivity ohm meter. Okay, that is ohm meter. Option C is the correct. Option C is the correct. Okay, and the next question. If the two resistors are 10 ohms and 10 ohms are connected in parallel, then combined resistance will be dash. Combined resistance will be dash. Here, whenever the two resistors are connected in parallel or any number of resistors are connected in parallel, then the total resistance R total 1 by R total is equal to 1 by R1 plus 1 by R2 plus and so on 1 by Rn. If they are connected in series, then R total is equal to sum of the individual resistances R1 plus R2 plus and so on Rn. Okay. But whenever we have the two resistors are in parallel, we can say 1 by R total is equal to two resistors only we have taken R1 plus R2. So we can say R total is equal to R1 R2 by R1 plus R2. It is better to remember. It is better to remember direct formula. R total is equal to R1 R2 by R1 plus R2. Here they have given 10 and 10 means 10 into 10 by 10 plus 10, that is 20. That is 100 by 20, that is equal to 5 ohms. 5 ohms is the answer. 5 ohms is the answer. And there is a simple trick also is there, that is whenever the resistors are equal, that is R comma R comma R comma R are connected in parallel. Then the equivalent resistance is equal to the resistance R by number of resistors. That is here the equal resistance R by number of resistors are two resistors are connected, that is R by 2. R is 10 by 2, that is equal to 5 ohms. So we can get simply the answer. You can get the answer simply. Okay. And the next question. If the two capacitors 10 microfarad and 10 microfarad are connected in parallel, then the combined capacitance will be dash. Here we have to aware on this capacitor formulas. Why? Because Here we know very well, if the resistors are connected in series, then R total is equal to just sum of their resistors. If the resistors are in parallel, we have to take the reciprocal sum, 1 by R1 plus 1 by R2 plus and so on. But in case of capacitors, if the capacitors are connected in series, then the total equivalent capacitance is equal to 1 by C1 plus 1 by C2 plus and so on, like this. If the capacitors are in parallel, then C total is equal to C1 plus C2 plus and so on. That means the formulas are just opposite. For resistors, for inductors, inductor is denoted by the letter L. For resistors and inductors, the formulas are same. For but capacitor, the formulas are different, opposite. Here they have given parallel means we have to use this formula. Only two resistors are given means, that is 10 plus 10, that is equal to 20. So option B, 20. Okay. Okay friends, in the next class we will discuss the remaining important MCQs in the case of physics. But don't forget, just open unacademy.com and here you have to just click on follow me button, open my profile, and don't forget click on follow me button. If you click on follow me button, then whenever I will take any special classes, you will get the notification. And if you watch the special class, you will get the PDF also. Okay. And anybody wants plus course in Unacademy Plus platform in any category, use this referral code Sunil sir, you will get 10% discount on that. Okay. For example, if you want subscription under railway examinations, just log in with your credential and select your goal. For example, if you want to coaching for SSC examinations, SSC CGL, CHSL, or SSC JE, or any examinations, any SSC examination, select your goal as SSC examinations. If you want IES, select IES. If you want GATE, select GATE. If you want bank, select bank, like this. Okay. After that, select the number of months, and then here you have to apply the referral code Sunil sir. If you apply the referral code, just click on apply, then you will get discount, 10% discount, like this. And if you have any credits in Unacademy, you can also use these credits, then you will get more discount. After that, you will get unlimited access to all the plus courses. Okay. Okay, thank you very much friends, and I want to see you tomorrow, that is Sunday, that is 2010-2019. I'm going to take two special classes, that is one is 9 a.m. and another one will be nearly, that is 10:30 a.m. Okay, don't forget, attend for these two classes, then you will also get PDF with the answers. Okay, so don't forget, please share this video and please like this video. Okay, I will always support you for your preparation. Thank you very much, students.